Hello students, today we are learning about symbol titration. Under symbol titration we have this question. Example, we have this question: you are provided with the following 4.2 gram of sodium hydroxide solution containing 250 centimeter cubic of volume of this solution. We have also 2 gram of hydrochloric acid containing 500 centimeter cubic of this solution. Then we have the procedure. The procedure is fill the burette with hydrochloric acid. Then Roman 2, we have procedure 2, using a pipette, place 25 centimeter cubic of sodium hydroxide, and you place in a clean conical flask. Then add 2 drops of indicator, especially methyl orange, and you carry out the titration. Then you fill the table. You fill the first table, titer 1, titer 2, titer 3, the 3 table. According to this practical, when we fill the table, we have 20 centimeter cubic, 20 centimeter cubic, 20 centimeter cubic, initial 00, and the final reading 2020. So this is the questions. Our target is the questions. Question A is saying calculate the average volume of HCl used. Average volume is equal to, then you add all the 3, then you divide by 2. 20 plus 20 plus 20 divided by 3. When you add the 320, you get 60. 60 divided by 20, you'll get 60 divided by 3, because they are 3 in number, then you'll get it 20 centimeter cubic of which solution? Of HCl used. This is the volume of HCl used. Part B is asking the concentration in gram per liter of sodium hydroxide. For you to calculate the concentration of sodium hydroxide, we have the mass and the total volume. Then we will say mass is equal to total volume, what about 1000? We have learned this one in lesson 18 and lesson 19. 4.2 gram is equal to the total volume, which is 250 centimeter cubic. What about 1000? What about 1000 centimeter cubic? Then you do is equal to x. Then you do cross multiplication. You cross multiply this one, then you cross multiply this one. Then after cross multiplication, we have 4.2 gram multiplied by 1000 centimeter cubic, then divided by 250 centimeter cubic. Through cancellation, centimeter cubic and centimeter cubic cancel. When we multiply 4.2 divided by 4.2 divided by 4.2 times first 1000, that is 4200, divided by 250. You will get 16. If I'm not wrong, you will get 16. Let me change my pen. You get 16.8 gram per liter. That is the concentration in RFM in part B, the concentration in gram per liter of sodium hydroxide. So let us also calculate the molarity, the concentration, but he is asking concentration in moles per liter. Concentration in moles per liter means molarity. Therefore, molarity can be obtained by using this formula. Molarity is equal to concentration in gram per liter over RFM. Then in concentration in gram per liter, we have already obtained in part B, which is 16.8 gram per liter. So let us get RFM. RFM is obtained how? How can we get RFM? RFM of which solution? The solution in part C they are asking is sodium hydroxide. RFM of sodium hydroxide will be how much? According to the last lessons that we have done, not last lesson, previous lessons, sodium is always 23 plus oxygen is 16. Sometimes they give you in the bracket plus hydrogen 1. Then you'll get 40. The RFM is for 40. Now, if you have the RFM 40 and you have concentration 16.8, therefore molarity is equal to concentration in gram per liter, which is 16.8 gram over RFM, which is 40. What do you get? 16.8 divided by 40. You'll get 0. The answer is 0.4 2 molar of sodium hydroxide. This is the molarity of sodium hydroxide. Good. But let us go but C. But C is asking the number of moles of sodium hydroxide used. Sorry, that was but C. We have done it. The concentration in moles per liter, we have done it 0.42. I mean but D. But D is asking the number of moles of sodium hydroxide used. How do we get the number of moles of sodium hydroxide used? Let us go to a new page. That is part D. Number of moles of sodium hydroxide used. For us to get it, what do we have? Sodium hydroxide. How can we get it? We have the molarity of sodium hydroxide right now. What you have obtained, the molarity here, which is 0.42, and also we have the volume used here, which is 25 centimeter cube of sodium hydroxide is used. So this is what we do. Then this is what we do. We will say it 0.42, which is the molarity of sodium hydroxide is equal to 1000. That we obtain in part B, part C I mean. What about the volume used, which is 25 centimeter cubic? This volume used that I am doing now here, if I go back to the question 1, the previous page, this is the volume of sodium hydroxide used, and this is the molarity. This molarity is equal to 1000. What about the volume? Volume used. Then it gives us the correct answer. The correct answer. So we do cross multiplication. 0.42 mole times 25 centimeter cubic divided by 1000. This is cross multiplication. We were cross multiplying. We multiply this one, then we also multiply this one. We multiply 0.4.2 times 25, then we divide 1000. So you cancel centimeter cubic and centimeter cubic, then this one times 0.42 times 25 divided by 1000. Then you will get the answer. The number of moles will be 0.0105 moles of sodium hydroxide sodium hydroxide. This is the number of moles of sodium hydroxide used. That's the number of moles of sodium hydroxide used. Next, let us also see the next question. But E, the number of moles of HCl. So how do you get the number of moles of HCl? The number of moles of HCl can be obtained through equation. How do you do that? That is part E. So you will react to the two solutions. Sodium hydroxide aqueous plus HCl aqueous. Then we react. The product will be sodium chloride aqueous plus water. Water liquid. Yes. And this equation, when we balance it, sodium 1, sodium 1, chlorine 1, then hydrogen 2 here, hydrogen 1 here, another one here, 2, oxygen 1 here, oxygen 1 in the water. It's balanced. So the mole ratio is 1 to 1. So therefore, if the mole ratio is 1 to 1, the number of moles remains the same. The number of moles of HCl, 0.105 moles. Of which solution? Of HCl. That's how you'll get it. Part E. Then we have F. F is asking, if we go to the previous page, part F is asking the mass of the sodium hydroxide used. So how do you get the mass of the sodium hydroxide used? Mass is equal to number of moles times RFM. Number of moles times RFM. What is the number of moles of sodium hydroxide? We have it here. It's here. It is 0.0105 mole times, we multiply the RFM. What is the RFM of sodium hydroxide? If I go back, I have already obtained it here. The RFM of sodium hydroxide is here, which is 440. When I added sodium 23, 16 oxygen, 1 hydrogen, then when I multiply 40, then what do I get it? Times 0.0105 times 40. What do I get? 0.42. My mass is 0.42 gram. So this is my mass. Okay, the next question is, let me go to the previous page. The next question is, after F we have the percentage purity of sodium hydroxide. How do you get the percentage purity? Next page, because this page is full there. We have F, then G. Question G, if I'm not wrong, the last question was F. Yes, question G is asking percentage purity. Percentage purity is equal to, then first we have to get the percentage used. The percentage used we have to get it, then we subtract 100. Percentage purity is equal to, this is what we do, the percentage used we get it, mass used all over the total mass times 100 percentage. You use this formula. Mass used is how much? If I go to previous page, mass used is this mass, which is this is the mass used. This is the mass used, 0.42. Then if I go back to the total mass of sodium hydroxide is 4.2. So therefore my mass is 0.4 gram. The mass used over total mass, which is 4.2 times 100%. How much do you get it here? This one divided by 0.42 divided by 4.2, then multiplied by 100. You get 10%. 10%. So this is 10% of sodium hydroxide is percentage purity is impure. So the purity of will be 100 minus 10. Then what do you get? You get 90% of this solution is pure. Is pure. 90% of this solution is pure. Thank you. This is how you do the questions, please, my friends. This is how you do the questions. If I summarize it, the question is 4.2 gram. So 4.2 gram of sodium hydroxide contains this volume. Then 2 gram of hydrochloric acid contains 500 centimeter cube of solution. Then they are asking you calculate. This is the procedure. Then this is the table. The table you get from the average volume. So this is what they said. Calculate the average volume. For you to calculate the average volume, this is how you do. You add the last 3. 1, 2, 3. All of them, they have the similar range. If the range is minus plus 0.2, then you can add all of them and you divide by 3. If they are too far away from their range, then you only use the closest one. Whether it's 2, you average the closest value. So here we have obtained the average volume 20 centimeter cubic by adding all of them and dividing 3. Then but P, it's asking the concentration in gram per liter of the sodium hydroxide. You have the mass 4.2 is equal to total volume. What about 1000? You cross multiply, then you get 16.8 gram. Then but C, it's asking molarity. For you to calculate the molarity, which is also the concentration in moles per liter minus the molarity. Molarity is equal to concentration gram per liter over RFM. Concentration gram per liter you have obtained in part B, which is 16.8 gram. You get the RFM of sodium hydroxide. Sodium 23, oxygen 16, hydrogen 1. Sometimes they give you in the bracket, sometimes they will not give you because you have learned it. Then you add all of them, 40. Then you divide by the concentration gram per liter, then you get 0.42 molar, which is sodium hydroxide. That's the molarity of sodium hydroxide. Part E, they ask the number of moles of HCl used. To get the number of moles of part D, the number of moles of sodium hydroxide used. To get the number of moles of sodium hydroxide used, you have the molarity, then you have the total the volume used, which is 225 centimeter. Then you will say 0.42 molarity is equal to 1025. How much? Cross multiplication, then you get this value. If they ask you the number of moles of the acid, then you add the two, you react to the two. Sodium hydroxide plus HCl, sodium chloride plus water. Then you balance the equation, then the mole ratio, you get it from there. If the two mole ratios